Distance.
Why distance? Because it says? Now, in the book, I think when you got to number 13, it just said closest, and some of you are probably like, but it's still an S, right? It's still a superlative. Closest minimum distance, the least distance from. So, my primary guy is going to be distance, and some of you guys figured out that formula. D is equal to the square root of, now, normally it'd be x2 minus x1, but how many points do I have?
One.
Just one. So I'm going to say, okay, I don't know one of the x's, but since I don't have two of them going on, I just need to put one x. I don't need to name it x2. I can just say 1x minus the other x value of 2, and a y minus 0. Since I'm not dealing with 2 points, I don't have to name it all those little superscripts. Sorry, subscripts. So that would be my distance formula. I could go ahead and simplify that a bit, but the dilemma is, remember once we find our main guy, once we identify our primary, isn't that the guy that we're trying to do calculus to in just a little bit? So if we're trying to find the minimum distance, I want to find d prime of x. That's how we've been doing it. But the dilemma is there's not just an x. What else is in there? There's a y.
Oh, wait.
So, my question was there any other clue that might help me? Any other equation, any other relationship? And the answer is?
Yes. Gotta get involved.
Yeah, gotta get excited. There he is. So, y equals square root of x, and do we even have to get y by itself?
Nope.
Nope, just go plug them in. So, when you get to something where it says something like a point on a curve, or here's a graph of a function, that will probably be your clue, because it's y equals, you can plug in for y in some other equation. I think that showed up at least a couple times in homework. Oops, there's my pencil. I just kicked my pencil. Go team. Anyway, coming back to this.
Let's go.
Now I have the expression. Now remember, when we take derivatives, we want things simplified. I'm going to go ahead and FOIL out, don't kill a puppy, FOIL out x minus 2 squared, which would be x squared minus 4x plus 4. I'm going to go ahead and plug in a square root of x squared.
Which would be x.
Yeah. So I plug in square root of x for y, the minus 0 just disappears. The square root squared is just going to be an x. And then I can go ahead and say, all right, cool. This will equal the square root of minus 3x. It's a negative and a positive. They're against each other. Now, here's the deal. I was actually really thankful, and this is, to be honest, I didn't watch the video before I assigned it, but I'm really thankful that the lady who had described or explained, remember online, the pink ones, you can watch videos, how to solve it. She explained the exact same way I would solve this, but it's weird. Normally we'd say, all right, let's go take a derivative. Aw, stink, we gotta use chain rule. Bring down the 1 half, make it a negative 1 half times u prime, and then go from there. Technically, that's right. But there is a shortcut whenever you're dealing with the distance formula, and here's the shortcut. Ready? Question. Is 25 less than 36?
Yes.
Okay. Is 25's square root less than 36's square root?
Yes.
Is that always going to be true? Mm-hmm. Is 49 less than 144?
Wait. Yes. 49.
Is 49's square root less than 144's?
Yes.
So, in order to get the least square root, you'll always be looking for the least argument. The smaller the argument, the smaller the square root, right? If you go from 36 to 25, well, 6 to 5, the square root just got smaller, and that's always true. The reason is because the square root function is strictly increasing. There's no like weird wobbling in between. No wibbly wobbly. You probably don't watch this show. But anyway, so there's no weirdness going on in between. So therefore we can say, well, if this is strictly increasing, I'm just looking for the lowest argument. So that's why some people would say something to the effect of, and I think she used z, so I'll use it too, not like a complex number, but just z. You can let z equal d squared and say, oh, hey, you know what? I'm only going to look at the inside. I'm only going to look at the inside of the square root. So if I want the lowest square root, I'll just look for the lowest inside. This only works when we're doing minimums and maximums, specifically minimums of square root functions, where there's no extra argument. If you've had x times, all bets are off. You can't go doing this. But since it's just a square root, we can say the square root will be the lowest when the inside is the lowest. totally true, totally valid. And so what I'm going to do is save myself some time and say, hey, let's not find the minimum z, sorry, I just gave it away, the minimum d. We're going to find the minimum z. Find the minimum inside, you're going to have the minimum square root. So therefore, we're going to do z prime. And why is that so cool?
It saves you chain rule.
Yeah, it saves us chain rule. It makes the derivative so much nicer. So the derivative is now just going to be, this is not the derivative of d. It's not. It's the derivative of the square of d. It's the derivative of the inside.
Okay.
We're just looking for that. And that's going to be, well, it's going to have a crit at,
3 times.
careful, 3 over 2. Do I have endpoints? Remember, we always have to ask ourselves endpoints.
Yep.
Ooh, this one, it tells us a domain. So therefore, the domain x is within, 0 to 3. So I have to test critical numbers and endpoints. Okay? How do I do that? How high is your y? Right? How high is your y? We plug it in a table. And say, all right, which one's going to have the lowest? Which one's going to have, well, we don't even need the highest. We just want the, nope, we do want closest to and greatest. So we want the lowest and the highest. So we're going to go ahead and plug in x's, and it's your guys' choice. Do you want to plug into z, d or z?
Z.
Okay, we'll plug into z. If they did want what the actual distance was, we'd have to actually plug into d, if they want the distance. But aren't they just asking for the points? Okay. So therefore I'm going to plug in 0. Whew, 3/2 is in between, or else we'd be in some trouble. We wouldn't be able to use it. But 3/2 is in between, so we'll use them. Plugging into z, 0, 0, 4. Square root of 4 would be if you want. We could make a, so d is 2, if you needed the distance. Plugging in 3/2, that would be 9/4 minus 9/2 would be negative 9/4 plus 8/4. Is that negative 1/4? Hold on, that doesn't make sense. Pause, I did it backwards. 9/4 minus 9/2 would be negative 9/4 plus, oh, 9/4. No. That's not right. I was doing a different denominator. 4 into fourths would be 16/4, right?
Yeah.
16/4 minus 9/4 would be 7/4. Square root of that would be square root of 7 over 2. Ugh. And then 3 would be 9 minus 9 is 0, and 0, 4. Okay. What do we got?
So your closest distance. Wait, what's
Closest distance, that's hard. Look here. 7/4 is like what? 1 3/4? Isn't that going to be my min? These are going to be tied for max. Oh my goodness. So therefore we could say, the point closest is 3/2, but wait, a point, isn't that an x and a y? And the points farthest, because there's 2 of them, are 0 and 3. Question. Nathan, what were you saying we need to do now to finish?
Plug it in.
Go back and say, well, if I have x, who's y? Well, the square root of 0 is 0. The square root of 3 is whatever, root 3, and the square root of 3/2 is whatever. Remember, ain't nobody got time to simplify in calc. There we go. They didn't ask for the distances. If they did, we could say, oh, the farthest it goes is 2 away from that point, and the closest it goes is root 7 over 2. But they didn't ask for it, so it's okay.
Hey,
It's okay.
for the other one.
Now, for those of you guys that got stuck at 13, this is how you want to do 13.
Will you always be able to just deal with the inside for the distance
Whenever
from
it's
anyone?
strictly a square root is.
Yeah.
And you're trying to minimize it.
Yeah.
Not if you're trying to do other things with calculus.
But
Yeah.
if,
Oh, sorry. Go ahead, Nathan, then we'll do Sean.
if you end up just deriving it like.
It would also work, yeah. You would end up with, at the end of the day, 1 over 2 square root of, which you'd be trying to find the DNEs, which is, I don't know, are there DNEs?
I mean,
There will be around 1 over 2.
I think they'd be outside the interval.
Yeah, probably.
But anyway, you would end up with the extra critical numbers, and long story short, they're not going to be important. And then on the top, you're gonna have your 2x minus 3, which is gonna be your 3 halves that you need. So yeah, you could just derive it, so it's just a shortcut, that's all it is. I was just wanting to explain how she did it, because some of you might go watch that video, because you forgot you put it on the paper. Sean?
For number 13,
Yeah.
it was also just, it was only the closest point.
Okay.
So then that was just finding a minimum, and
Right.
when you find your crit, there would be that only 1 point, so couldn't you use a sign chart?
You could use a sign chart as long as it's strictly decreasing than
Yeah.
increasing. But since you had the endpoints, whichever one's easier to you, both would prove it's a min.
There were no endpoints, it was a continuous function.
Oh, so yeah, you would do behavior then. So remember, we only do endpoints when they cut it, because when you cut it, let me just, I don't know, give me some random function.
X cubed.
X cubed, okay. Let's say it's like a distorted x cubed, okay? And let's say they make the endpoints to be something like this and this. Well, that doesn't help. There we go, and this. They cut it randomly. I can find mins and maxes inside, but I have to still test the endpoints because maybe one of them is going to be an absolute. Does that make sense? All right, cool kids, let's zero in. Remember, this is important stuff. We can't just, especially this one.
Good. I like this one.
You can't just sit here and pretend it's just gonna go in. We have to fully commit. So here we go. How do you see it? Concept-y. All right?
Go.
Concept-y. Let's see what we got. I'm gonna turn off one of the lights so that we can see it a little better.
Oh
The
dear.
graph is kind of funny.
She a nice graph.
Is there
How do you see it? The graph shows profit in thousands of
the
dollars
more they spend on advertising, they get less
of a company in
and
terms of its advertising cost. So how much is it spending on this makes sense in a business, right?
Yeah.
How much are you spending on advertising versus how much is coming in? Because if you're spending lots of money and not making any, what's the point? Or you need to change whatever you're doing. Something's wrong. Your advertising stinks. But if you're not spending very much, or if you are spending a lot and making a lot more as a result, okay. So they're spending 10, 20, 30 thousands of dollars on advertising and they're making, whoa, looks pretty good, but still, you know, business people, they want to make the best,
optimize.
the optimal situation as far as what they're making versus what they're spending. First of all, letter A. Where is profit increasing?
It's like
From like
$0
to like 40.
Why are you allowed just to look at it and say, where is it going up? It says, where is profit increasing, and this is profit. Oh yeah, you're just looking at it and saying, where is it going up? It's going up front, you're totally right. From 0-ish to
40-ish.
yeah, we can say 40-ish. You want to make 40 that max?
Yeah.
Remember, or in the book, they don't always label things quite as nicely as they should. It's close. Estimate the interval in which the profit is decreasing. Oh, it's profit, look at it. It's going down from,
40 to 60.
good. Estimate the amount of money the company should spend on advertising in order to yield a maximum profit.
Well, that would be at the max.
$40,000.
So like $40,000.
Yeah. So you could say, but if you want to put it in context, you could say $40,000, that's okay. Now, letter D, the point of diminishing returns is the point at which the rate of growth of the profit function begins to decline. Estimate the point of diminishing returns.
40.
Not 40.
No, it'd be like 41.
No,
Wait, 1.
it's
35.
not even close to 40. Well, I mean, it's
35. Dude, but like.
not 35. Pause. Gotta read it. This
Oh,
has to
so
do
it's
with,
like-
Sean,
it's the
help me out. The
inflection
one where it
point.
was
It's at like
increasing
20
most
or
rapidly.
something.
What problem is that? 50-something?
It's the F double prime.
That's number 40.
It's the-
Wait,
It's
46. Oh,
It's
I got
the
you. I got
inflection
you.
point,
Okay,
Steve.
in your homework, there's a problem.
41.
And the
So
problem says, where or when is a function increasing most rapidly? What are you trying to find the maximum of? The max of the function?
No,
Listen to the words, increasing most rapidly. There is a most,
the max of the F prime.
the max of the rate. So if it says increasing fastest, increasing most rapidly, that's asking for the maximum rate, which means the maximum derivative. Look at this one. The point at which the rate of growth begins to decline. It's going to decline at its max. This function at its maximum profit, at its maximum, starts to decline after. Not every function behaves that way. But most functions at their maximum, they're increasing before and decreasing after. So at the profit's maximum, increasing before, increasing after. But the problem is, on letter D, it's not saying profit, it's saying rate. What or how do you see a rate when looking at a graph of a quantity?
Tangent.
Slopes, tangent lines. So skim, where does the slope get steepest positively?
Right before.
This is kind of zero-ish, right?
At the 20.
Steeper, 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 steeper. All of a sudden, ooh. What's going on to the rate? At the point of inflection?
20-ish.
20-ish. The point of inflection is where it changes concavity. Concavity, the derivative is, this is concave up. Do you guys see it?
Yeah.
Concave up with the cup because the derivative, the rate is increasing. Concave up. Now the rate is decreasing. Concave down. The point, which we would call the inflection point, is the point of diminishing returns. That would be it. That would be it. Okay, now, I know that this is not an econ class, this is not a business class, I got that. This is not an accounting class, I got that. But this helps us in calculus think through if they ask us for the max or min, not of a quantity, but of its rate. We have to look beyond what we're used to. Okay, we have to look beyond what we're used to. Let's go ahead and talk about one other funny thing that can happen. Let me pause for a second and go back. I don't think that's enough to really help you when you get to that homework problem. So give me a quick second. In your notes. Don't write down point of diminishing returns unless you already wrote it down. Don't make a big deal about that. You don't have to memorize the point of diminishing returns. Once again, not econ, not accounting. But what I do want you to write down is something to the effect of how to deal with maximize or minimize rate. Okay, write down something to the effect of, this is just like an example of the type of problem. It's super tricky, but if you love to use it. Max or min, no big deal, rate. Okay, we need to maximize or minimize rate. So, our primary would be the rate. And normally, if it's the rate of, like f, for instance, the rate, our primary would be f prime. And that's a struggle, because then when we go to do our find, either the max or the min of the rate, my guys that have already dealt with this, if we already have f prime, what do we do when we go to do primary prime? We have to do f double prime. Well, I'm going to do the pitchfork because it's possible f double prime will have zeros and DNEs, and if they do, we have to look at the critical numbers from the top and the bottom. We've just gotten a little lazy because we've only had functions with tops, but we'll find our critical numbers from f double prime. Now, really quickly, what are some ways that this wording can show up? It can be increasing or decreasing, most or least rapidly. That's one way that you can see it, increasing or decreasing, most or least rapidly, depends on which one. Increasing or decreasing, most or least rapidly. But they could also ask you something to the effect of the greatest or the least rate. The nice thing is, if rate is in there, hopefully you guys would attach it to primary. If they put the word rate, hopefully you would attach it to primary. The struggle is if they say increasing or decreasing most rapidly, there's no rate word in there. But it still means, hey, it's going up faster or it's going down faster. It's still talking about slopes of tangent lines, still talking about rate. So anyway, this is just like a, I don't know, problem-solving clue. Not like a but just some hints because this does show up from time to time. And you guys have it if you want to write it down. Did you guys figure it out? 46?
It's 41.
41. Homework problem number 41. You will need to use this idea.
Yeah, it's weird.
Okay? Tyler, do you have a question, bud?
Yeah, if this is f prime, then what is f measure? Like, what's the y-axis of f in?
On this profit example or on this
Yeah,
example?
On the profit example, like, what's f?
Profit, F would be profit.
Oh, really? Okay.
Yeah. F prime would be how fast or the rate at which profit is increasing or decreasing. The second derivative, how fast the rate is changing. The acceleration of the profit, yeah, I don't know. Okay. Good thing is, this example does not have the whole rate question. Okay, good. This example does not have the whole rate question, but it's weird in another way. The people who tried homework, I'm not exactly sure if you saw one, just the AP turns that if you didn't.
Well, this is like one where they don't actually give you numbers.
Yeah,
And they'll probably give you a related rates problem in the same FRQ.
they might. They might. In word problems, it's very possible that a related rates might be like part A, but a max or min could be like part B, and then like a plugging in or using a graph might be like part C, but
Oh, that's right.
it's okay, it's okay. Those are the ones you just gotta dig in. When it gets hard, you just gotta dig in. That's what our culture does. That's what we do.
We're not Japanese or
We won't
Americans.
succeed, yeah. That's not a good thing.
Did you still use that example?
I haven't yet. I should. Not everybody had me last year, but those that did, the study about the, I actually figured out, I think they were kindergartners.
Oh, that's cool.
It's
They were some sort of-
early.
Yeah, they were some sort of lower elementary,
Even in function,
which, that's good for you guys to realize. That literally laziness gets ingrained early, and so we have to fight it. And apathy. Okay, a rectangular container with 2 square sides and an open top is to have a volume of V cubic units. You guys understand why I'm drawing bottles, right?
Yep.
Rough.
By 2 square sides, does it mean that it's like a perfect cube? Or
So it says 2 square sides, so then this one I could label as, for instance, X and X.
Oh, okay.
So that would be square, but then this one could be rectangular. So they only said 2 sides had to be
it's the
square.
opposite sides of it.
Yeah. The volume of V cubic units. Find the dimensions of a container with a minimum surface area. Okay, primary. Some of you got in a habit, if you did like the first 2 or 3 or 4 problems, and for those of you that didn't, you gotta do the first 2 or 3 or 4 to get in this habit. It's a good habit. You realized, hey, the secondary almost always has a number.
Yeah.
Something equals 108, something equals 52, something equals 47. I'm making up numbers, but the secondary almost always has a number, because then you can solve for one variable and plug in. The dilemma is, are there any numbers? Oh. Okay, hold on. Use the wording. Question, who's our main guy?
Surface area of,
Yeah. You see the minimum, right? So surface area, I should call it A for area, is that okay? Now, a little bit of a dilemma, we have to go back to geometry just a little bit. We do have this square times 2, so we have 2x squared. We have 2 of those sides. We have this side, this is the base, which would be x times y. We only have one of those because it says open on top. So we only have one of the bases. Only have a bottom, not a top. Ooh, but we also have this side, right? 2 of those, and it's going to be y and x again because of that little square. Okay, so we have another 2. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, cool. We could combine those 2 since they're like terms, and we could say total 2x squared plus 3xy. We want to find the minimum A, right? Which means we do calculus to A, which means we want A prime. But dilemma, don't I just want A prime of x or of one variable? Who doesn't belong?
That y.
Okay, let's get rid of them. What's our clue? Wait, there's no number. I don't care. What's our clue? What else do they talk
That
about?
is constant.
Volume. volume of this box is going to be length times width times height, x times y, so x squared y. Length times width times height, and since they said square, I was able to say width and height are the same, x times y. Dilemma. They say, is to have a volume of V. Struggle. This is them saying, treat this guy like he's a constant. Ooh. But no, I think of him as a variable. I know, but he's standing for a constant. Meaning, let me try to give you a reason why real quick. Meaning, if you were trying to pitch something to a company, and if they hadn't decided quite what volume they wanted, but they were like, no, but or you're going to multiple companies and all of them have different volumes. Because you're a manufacturer of like a container for them. You could say, hey, if you give us a volume of how much you want to fit, we can tell you the piece of material you'll have to use if you're going to use rectangular shipping or rectangular containers for your product that you want to put in. Like, you figure out how much of the product you want to sell, and then we'll tell you the way, the dimensions to make your box to have the least material. Okay? So this is like, they're going to give me a number. What is it? I don't know. I have to leave a place for it, but they're going to give me a number. And it could be different based on the different companies I go to. That's just like a little quick, oh, all right, sure. They'll give me their number, and I'll go for it. So they're not going to tell us just 108. They're not going to tell us just 49. They're going to tell us just use V and make them a constant, which means I still solve for y, and it's okay that the v is still in there because he's a constant. He's not a variable. So when I go take a derivative, I'm treating him like a constant, not a variable, so it's legal. So when I go to solve for a, or to simplify, to rewrite a, I'll end up with 2x squared plus, 3x times v over x squared. One of the x's, good, cancels. One of the x's reduces, I should say. I have 3 times v over x, but this is different. The y was constantly changing depending, well, I shouldn't say constantly changing, was changing based on the different volumes, but v is set from the company. They'll tell me a number, and then we'll just use it. V does not change. It's given to me. So therefore, it's time for me to take a derivative. The v is not a problem. It is a function solely in terms of x as far as variables. So I can go ahead and say the derivative of 2x squared is 4x. The derivative of 3v over x is negative 3v over x squared, because if I were to go and take the derivative of 3v over x, I could make it the derivative, just like we did yesterday, of 3v x to the negative 1. And that v, I'm treating like a constant, which means constant multiple, keep the 3, keep the v, bring down the negative 1, make it a negative 2. It behaves the same way as though I knew the number and I plugged it in. I know it's weird, I know it's out there, but whenever they say something about defining or determining or establishing some sort of set number, but they don't give it to you, you use that variable and say, hey, he's a constant. So now I'm going to say, it's time for critical numbers. Tyler, go ahead.
So if you want to match up the bases, like over x squared, and you multiply by, well, I guess we'll multiply by x squared over x squared,
Yeah.
Okay.
Very common denominator, because you want one top, one bottom. So what did I do? I said, ooh, he doesn't have a denominator. Let's multiply him by x squared over x squared.
Sorry, I was seeing something.
Now I do my pitchfork. Quick question. How practical, how helpful is this box going to be if x is 0?
That's it works.
Nothing. It's going to be a line of material. That's lame. So therefore, even though the bottom says x equals 0, that's impossible. It can't be in the domain. I wouldn't have a box. On top, I would solve for x, and I would get x equals 3v over 4 cubed rooted. Ugh. But true. Add 3v because I'm setting equal to 0, right? That one's illegal because I can't have a box if x is 0. Add the 3v, divide by 4, cube root both sides. We technically don't have endpoints because x can't be 0. And they don't necessarily tell us this is multiplying. As x gets bigger, y gets smaller, and y can get infinitesimally close to 0. Long story short, no
Is
endpoints.
that, and then you just find the area is just that squared. Like, area divided by that squared is the y?
No, but we would just plug right back in, right?
Yeah.
Huh?
Like for the other formula, the v
Oh, we still
over
have to
x
check
squared.
if it's min and max.
Oh, we're just doing the behavior real quick.
Oh,
Because they just say, find the dimensions of the container with minimum surface area. So x will be, and then we'll find y, so we'll do x by y. No big deal. Long story short, if you were to plug in something less than, like say 1, well, we don't know exactly what v is, but if you were to plug in something a little bit lower than this expression to x, there we go, a little bit lower, when you cube it and undo everything, it's going to end up not being as big, which means that is going to end up being a negative. If you plug in something bigger and cube it, you'd have to actually like add a 1 and then have to simplify, it'd be really gross, but it will end up being a positive. Remember, this is just a double check. If there's only one critical number, if you've done all your work right, it will be the answer. So we can end up with the dimensions would be the cubed root of 3v over 4 by the cubed root of 3v over 4 by, because it's x by y. Ugh. Y, plug it in, plug it in. V over the cubed root of 3v over 4 squared. Because the cubed root and then squared. Anyway, it's going to be nasty, it's going to have variables, it's not going to be nice and neat with numbers, and that's perfectly right. Perfectly correct, perfectly right. I had some of you guys asking me questions on optimization-y things in 0 period. We covered the distancy one, we covered the funny number 41 one. Those of you that tried homework, is there something else in particular that you think we should talk about?
The semicircle,
Yes.
Okay.
rectangle.
What number is that? The Norman window.
Square. No,
No,
not the Norman.
Well, okay,
Oh,
yes,
yes,
that
Norman.
one too.
No.
Oh. Got it. It's number something towards the end.
Function.
Yeah. Here we go.
What?
No, 25, number 25.
Yeah, so it's 25 and 21 was.
Okay, I'll give you a hint on number 25. The Norman window, at least you guys have the picture.
Okay.
It's just trying to figure out the geometry of what they're talking about.
So bad.
And I think the Norman window one, was that an odd?
Yes, number
21, I think.
Okay, okay. So you can look at the geometry. This one's funny because there is no picture. So let me help out real quick. This is a parabola shifted up
No,
25.
there is a picture.
It's going to have 0. Oh, it does?
Yeah.
Negative 5 and 5.
There it is. It's just on the past. Yeah, it's on the bottom. It's not like near.
Oh, if you didn't see the picture, that'd be nasty. You have a rectangle.
y equals the square root of
This is
square root of 25 minus 6.
Oh, it's square root?
Yes, so it's
Oh, someone wrote it wrong this morning. I thought it was square root. Maybe
No.
Because it's
I
just
mean,
a
this is
symmetry.
54.
Oh, this is 54.
Yeah.
Okay, you guys just gave me the wrong one. Oh,
It's
okay.
now 54, okay.
All right.
Oh,
Now I'm helping you with
54 was
54.
one, But 24 was far less.
I think it's the same idea, isn't it?
No,
Well,
that one was the same.
It would be.
Yeah, but it would,
The square
the
root.
derivative would be
Yeah,
harder.
it's still the same thing.
Are you trying to find the maximum area?
Yeah.
It's
Okay. Primary, maximum area, right? Okay. So A equals,
X4. No, wait, no.
X and Y is where it hits over here. X
It's 2.
is only halfway. Y,
It's
so I need
2x.
2x y. X goes from the origin out to the point. I need 2 x's to be my entire base of my rectangle. I need 2 x's to be the entire base. That's where this gets funny. It was a pre-cal thing that we saw in honors last year. Regular, we might have skipped it. When you have an xy, x is only half the distance of the base, so I need 2 of them. Y will be the entire distance to the height, depending on how it's drawn. But I have too many variables. Is there a clue?
Right there, you're right there.
I know who Y is. Plug it in, plug it in. Go find your clue. What? It's 5 minute bell, that's weird. A equals 2x times 25 minus x squared. Our point is to find the max area. I want to do a prime. Well guys, at this point, just rewrite it to make it nice and take a derivative, right? P.S. From your classmates, number 25 is super similar. Super similar.
But this one's a lot easier.
It's
This
ugly.
one's derivative is nicer. This one's derivative is nicer. But at the end of the day, your process remains the same in that our goal now is to find the max, and to find the max, we take the primary, take your main guy, and say it's time for you to be primed, right? Yes, I know his derivative was easier. I didn't purposely choose the easier one. This was the one someone specifically asked me about. So
Blame you.
I just went for it. Okay, people that tried homework, I think I've gone over most of the really weird ones.
Yeah.
All right, for tomorrow,
Have it all done.
finish up this homework. Look at the videos of the pink ones, guys, if there are pink ones. We are going to do some like bell work or workspace work. Never mind, back to your spirals. Let's not go to 3-7 today. I want you to just have optimization in your minds, maxes and mins in your minds. I don't want to distract you right now. So, you need to try this homework tonight because we're going to a new section tomorrow that's going to be different. Not as lengthy in the sense of like having to read and analyze, but it's going to be a switch in thinking. So you need to work on this homework and for your brain give it time to digest, okay? What's chewing the cud? How do cows eat?
They regurgitate.
It's kind of gross, but they work on it and then it comes back up and I work on it and then I need you to do that with math. It's not as gross, well it might be, but I need you to do that or else you won't get it. Okay, workspace, back to your spirals.
And our other clue is what?
What was the, Sean, what was the formula?
Let's see if we can get the one multiple choice, number 52.
Was it 25 minus?
The one multiple choice, number 52.
You have to just.
If you don't have your spiral, okay, fine, in your notes.
So it's 50x minus 2x.
Is the basin? Never mind. That's right. Okay.
So we're drawing it from, right?
Oh, wasn't this, we're doing.
Number 52, just the multiple choice. Back to your spiral.
Homework.
Just the
But I
one
still
multiple
didn't
choice?
understand it.
We'll get a 2 or free response, we won't get that done. Can you get number 52?
Let's see. So
Okay, so it was max area. We're maximizing area, that's a primary.
We used 1/2 base plus minus
Main guy, area of a triangle, 1/2 base height. Why don't you do 1/2 x, y?
AB.
Draw a triangle.
AB, or
AB,
AB, because
x,
we have
y.
a C, and then that's our secondary.
I did do the.
oh no.
But then
Derived as Misty.
Pythagorean theorem is.
Oh, Misty,
solve
it's
for
just it's too ugly.
B equals the square root of 12 squared minus a squared.
We got to do it, but it's just ugly.
A times the square root of 12.
Oh, why do you
minus
use
a
x,
squared.
y? I use B and A.
You can use B and A, you can use x and y, it doesn't matter.
It's just so ugly.
Wait a minute, but I can't do A prime. I am going to find the max area. I can't do A prime, there's too many variables.
Stop a secondary.
Yeah, I use.
I have a clue.
Yeah, it's just 144 equals b squared plus a.
I have Pythagorean.
But it's ugly.
Wait, you square it?
Oh my gosh, that's why.
Yeah.
What?
then you take
I
that.
just did 12.
Question, did they write Pythagorean theorem in this? But it was
No.
there if you just went looking for a clue. Because then you can go ahead and plug in.
Nice job.
You end up with.
What up?
But Misty, that's just so ugly, Leslie. Because you
Now, are you going to enjoy doing this derivative?
No.
No, but you're deriving. That's review. Work on it little bit by little bit and see if you can get it. But do you get how to set it up?
It's good.
I just don't have the time to do it. What?
Maybe.
Wait, square root 32 plus what?
Second D first plus first D second would be 1/4.
Do that.
But see, Misty, where do you go once you get the ugliest answer known to mankind? You can't simplify.
You can get a common denominator, so that'd be 1/2.
Actually, it's too bad.
Pull it out, and then you're like,
But then you still get like the ugliest answer to mankind, and then you can't find
Yeah, I
the
got
zeros. Because you can match it up.
Ah, test, you guys, it doesn't work. Come get it to me today if you want it, otherwise remind me to be getting it tomorrow. What's the answer? I won't be able to get it all to you before you have to leave.
You get such an ugly answer that, like, where do you go?
I have it all wrong.
Forever quiz, lunchtime today, makeup! Forever quiz, lunchtime today, it's on the board and I'm trying to remind you. In my room, yeah, good, thanks, Zach.
Someone please we're feeling single.
I mean, it could hurt, but I'm gonna think it's okay. I don't know what I got.
Yeah, I'd change it.
I have to go all the way across campus.
Me too. Remind me later, I'll get it for you guys. Thank you. Is this the exact same one? You should see. Good. No, I got 2. Oh, I reduced.
Oh, you know, one for
Yeah, over 2. You're over 4. I think it's okay.
I hate life. I officially hate it.
Don't hate life? Why?
There's no more donuts. There's a soda box.
Jackie, throw it away and you and Lady can have my last 2.
What? Wait, what?
I saved him for David. He didn't want him. There's one.
Thank you. David. Thank you. It's wearing this leave. This is the biggest clickbait thing.
I'm really sorry.
I saw the box.
Thank you, Steve. Spill coffee because I was jumping around with my coffee.
I just mixed it with coffee.
Too much calculus excitement today.
I don't drink coffee. I don't like the way it tastes.
I didn't until I went to college and I started drinking it, and I just never really stopped.
Did you like need it in college? Was that it?
Yes, I did. Or at least I thought I did. It would make me feel like I'm being like responsible drinking my coffee to stay up late. I would just end up falling asleep with my coffee like sitting on my bed.
In my hand.
Yeah.
I saw it this morning. One word. My question is